Hello. Good morning, esteemed dignitaries and valued participants. I am Ravi Kumar, Under Secretary. And on behalf of the Ministry of Housing and Urban Affairs, I am privileged and honored to welcome you all to the 18th UMI Conference 2025. This research symposium is on freight infrastructure and multimodal integrity. And the session is being graciously chaired by Professor B.K. Bhavatratnan, Associate Professor in IIT Palghat. Guiding the discussion as the rapporteur is Ms. Devjani Panda. Now I would request Ms. Devjani Panda to start the session, please.
It is my pleasure, and I would like to invite Professor B.K. Bhavatrathan to start with session. Over to you, sir.
Thank you. Thank you, both of you. Very good morning. So, we have a session on freight infrastructure, infrastructure and multimodal integration, I believe, because it's not just about all papers are not just about freight infrastructure, I can see. So I am hoping that all presenters are here. Paper number 1, Varsha Yadav, I think she has reported. Hi. Smith Sarthak Mohanty, you are also here. Bala Ishwari is yet to come. We hope they will join. Sitanshu Kumar Das, you are here. Amardeep Pandey is here. No. Sujit Sahu is also known. So we can hope that they will join us. Meanwhile, we'll start presuming that all of them will be here, meaning all of them will need time. So let's stick to the timing of 15 minutes. Probably you can spend 10-12 minutes presenting, and then 3 minutes of Q&A. And then if at all, we do have get some time at the end, then we'll carry on with the discussions, come back for the questions later. So I am Bhavatrathan. I am an associate professor in transport systems in IIT Palakkad, the southernmost IIT in India. So we'll start straight away. I would invite Varsha Yadav, who will be presenting on a framework for assessing the multimodal integration at the interchange hubs. So, Ms. Devanjani, you will be keeping time, right? Please keep time.
So, good morning, everybody. Myself, Varsha Yadav. Today, I am going to present on the paper title, A Framework for Assessing the Multimodal Integration at the Interchange Hubs. So let's try to understand what is multimodal integration. So multimodal integration is the integrated network of transport system in which all the modes are interconnected to each other so that one mode cannot operate in isolation. So this is depicted in figure 1. All the roads, transit stations, transit links, airport and corridors all are interconnected to each other. And there are 5 pillars of multimodal integration. First one is the physical integration, that is the distance proximity between the modes. Second is the network or operational integration, which is defined as the coordinated services and schedules for all the modes. And third one is the fare integration, which is the integration of the fare, the availability of a single card or a common card for all the modes. And fourth one is the information integration, which is the availability of information on a common website or app related to the routes, fares, schedules, and services. The fifth one and the most important is the institutional integration, which is defined as the single organization framework for all the modes. Now the motivation of the study is that due to the lack of institutional, operational, and physical integration, the different modes are introduced at different time frame in a city, due to which the coordination between the modes is not happening, and the haphazard allocation of the spaces due to for the various modes which are causing entry and exit issues. The example is the Charwag station, in which there are passengers are reporting entry and exit issues, and the time penalty to the passengers due to the uncoordinated services, absence of proper information, and the increase in the discomfort and inconvenience due to the non-availability of the any design and layout guidelines, which are leading to the undue priority to the non-sustainable modes at the interchange hubs. And there is an increase in conflicts between the vehicle and vehicle passengers, and the uncomfortable inter-terminal movements. And second is the non-availability of the integrated single card, that is the part of fare integration. The time penalty is increasing, and passengers are reporting continuous dissatisfaction to the public transport. So the literature review mainly focus on the frameworks which are related to the index-based framework and the scoring-based framework. For forming the index for the framework, the methods like Topsys and entropy method, AHP method are used for forming the final index. And for scoring system, they are mainly focusing on the statistical analysis. So these are the different studies which are conducted in different countries. China is the leading in this interchange hubs related studies. The India is lacking behind, only few studies are available. And the available ones are mainly focusing on the service quality evaluation rather than the framework or any other type of analysis. So in the literature, the less studies are available on the performance of the interchange hubs. The available ones are using the more or less similar key factors for in the evaluation framework, and the evaluation framework mainly focusing on the certain aspects that is only related to operational, functional, or layout. Overall framework which is considering all the integration, that is the 5 pillars of integration, is missing in the literature, and the available studies are case sensitive and lacks universal applicability. And the benchmarking mechanism or framework is also missing in the literature for the interchange hubs. And the practical tool for assessing the multimodal integration at the interchange hubs, which can be useful for the practitioners or the policymakers, is also missing. So this is the overall methodology which is used in this paper to define the overall framework. Firstly, the key factors related to multimodal integration is identified from the literature. Then quantification of indicators has been done to arrive at the certain score for the certain indicator. Then the expert survey is conducted for finding the importance weight of the key factors and domain. And for finding the multimodal score of the certain at the interchange, the data related to inventory survey or passenger survey will be used to find the final multimodality score of the interchange. So these are the different key factors which are used in these studies, are identified from the literature, which are categorized into 4 domains, which are representative of the 5 pillars of integration. The 4 categories are infrastructure related, information related, operational related, or layout and ambience related. A set of 30 key factors is identified. Now, the quantification of the key factors. So literature is quantifying the factors based on the absence or full presence, and they are using 0-1 score for that, or the yes-no score for the absent and full presence. And the 3-point scale for 0, 0.5, and 1 is also used for quantification. Another is criteria is percentage of passengers who are agreed on a certain criteria is also used for the quantification, and based on the percentage, the value is used as a score. And another criteria is 0, 1, that is failed to meet even one criteria, they are assigning 0. And for fulfilling all the criteria, they are assigning 1. And another is the 5-point scale, that is the passenger's willingness, which is related to passenger satisfaction. On that Likert scale, they are using 1 to 5 for defining the quantification. So considering all these studies, a 5-point scale scoring system with a minimum 1 and maximum 5 for all the indicators in this study is done. And for generating the final multimodality index, the AHP method is used. And for defining the weight of the key factors within the domain, a 3-point score system is used. That is score 1, which is defining that the importance of KF is low and its absence will not have an impact on the overall performance. And score 2, which is defining the importance of KF is medium within the domain and its absence will impact the overall performance in that domain. The score 3 is used for defining that the importance of KF is high and its absence will significantly impact the overall performance in that domain. So these two methods are used for defining the weights for the key factors and the domain. And now the data collection approaches, as I explained, that expert survey will be used for defining the weights of the indicator and the final multimodality index is generated. And now to find the key factor score, the inventory data and the passenger survey data on the scale of 1 to 5, that is the Likert scale, and the inventory data which will define the existing condition at the interchange hubs will be used to define the score at the interchange hub. Now the passenger survey is used on the Likert scale, that is 1 to 5, very dissatisfied to very satisfied. And for expert survey, as I explained, that 3-point score will be used. So this is an illustration how to take the key factor score within that domain. This is the example of information domain. So there are 5 factors which will be scored on the 1 to 3 score. And the experts from the platforms like Google Scholar, ResearchGate, LinkedIn, and government and educational websites will be identified, and criteria for selecting the experts is they are mainly focusing on the transportation planning. Those who are working on transportation planning or directly involved in the multimodal integration related work, they will be defined. And for finding the final domain weights, AHP will be used, so the linguistic scale, that is SETI scale, is converted into this linguistic scale rather than the CRISP value. We are using the linguistic value, and on that basis we are defining, getting the scores for the domains. So this is the application and tentative approach, how this framework will work. So ABC are the 3 hypothetical locations, and these are the first column is defining the different key factors within the domain, and second column is defining their weights within that domain. So the overall weight will be 1 for each of the domain, and the score will be multiplied with the weight, and the final score of that domain, all the summation will be done, and final multimodality score will be defined. So this is the final multimodality score of 3 locations, A, B, C, and C is the having the highest weight, highest score, while V is underperforming. So conclusion is that the proposed framework is based on the qualitative and quantitative approaches. Both type of indicators in this framework is used, which is missing in the literature. They are either focusing on the quantitative or qualitative. Whole set of defining multimodal integration is used in this analysis. And the proposed framework considers a different type of data, that is the inventory data, which defines the existing condition, passenger opinion, which is defining the satisfaction rating, expert opinion, the attributes weights are defined on the expert opinion, and all the aspects related to multimodal integration has been used in this study. And the proposed framework is comprehensive and universal applicable in any of the city or any of the country. And the proposed framework is a practical tool which can be used by the professionals or policymakers. And this system allows us to identify the attributes which are underperforming, and improvements measures are also defined in this framework in the form of quantification of indicators. So these are the frameworks. Thank you.
Yeah, thank you, Ms. Varsha, for nice presentation and also sticking to the time. The floor is open for questions. I would request the audience here. Yes, please. Do we have a mic?
For that, for KFs within the domain, we are using the 3-point scale, that is score 1, score 2, and score 3, which is defining the relevance of that indicator within the domain. Like if I am using the ambience and temperature. So how ambience is important at in that domain, and how temperature is important in that domain, that is taken in the score form 1, 2, 3. Then the weights are defined.
I mean, from the Likert scale, you are actually taking the response of the different experts. But how did you decide the weight? I am asking. Like you are assigning some value 0.22, 0.1, 0.3, and then you total it to 1, right? So how are you deciding that weight? That 22% weightage will be given to a certain factor, 11% will be given to a certain factor. So how did you decide those weights? That's the only thing I want.
Okay. So firstly, the scores will be taken on 1, 2, 3. Then it will be divided on some methods like rigid method or Topsis method. It is defined, the ranking of that attributes will be given, and then the weights are defined.
So I think what she means, if I'm right, I think the experts decide the weight. Eventually the responses from the experts decides the weight.
Yes.
So you curate the results, Likert scale results from the experts, and then that's converted into the weights. But to extend that, why should the weights of what matters on performance of an interchange, what matters, and the weights are decided by the experts, is what you're saying. Your methodology pivots on the experts, decision on the weights. Why not the users?
Sir, actually users can define only the satisfaction rating, what are the existing conditions, and the importance weight of a certain factor will always be go for the expert opinion, because those who are professional, they well know which attribute is important in that domain. Rather than going for the passengers, they will define the general understanding.
Yeah, don't you think that also, wouldn't it also matter, like what a passenger sees as an important aspect of efficiency? Wouldn't that also, would we also not trust the passengers' opinions about that?
Sir, we can
anyway, it's just a thought to consider, food for thought.
Yeah.
We'll have that discussion later on also. Thank you. Any further questions, anyone? Yes, please.
Actually, there are just 3 locations. One is underperforming, you said, and one is performing well. But the scores difference I observed was 2.8 and 3.1 only. So any criteria for underperforming? So
no, in comparison of 3, the B is underperforming and C is overperforming in the comparison scale of A, B, C only. 3 locations.
So there is no rational, matlab, unless, and other than this comparative, nothing is there.
Yeah, that is totally based on the indicator score, the existing condition and the passenger survey, what passenger perceive at that and what is the existing condition. On that basis, the whole multimodality score is defined, and that the comparison scale is 1 to 5. The maximum score will be 5 and minimum score will be 1. So I think for that the score was 3.19.
Sorry to intervene. I think that micro details we can have later. In case we get time towards the end or after during the tea, we'll have the micro details and discussions. So any other higher level questions? If not, we can move on to the next.
How many experts for expert survey? How many experts have been response of experts has been taken for the study, and
Sir,
how the data how it has been collected?
Sir, actually, we have floated to 85 professional experts, where only 42 has responded. So the data of 42 is different.
Yeah, thank you. In the interest of time, let's move on. Thank you. I am sure we have questions more, but thanks, Ms. Varsha. We now move on to the next presentation. It's by Smith Sarthak Mohanty. Sanjay Gupta is also a co-author. Yeah, please go ahead. Please try to stick to the time so that, because we are running a bit behind.
Hello. A very good morning to everyone, to all the delegates present over here. I'm Smith Sarthak Mohanty, postgraduate student of School of Planning and Architecture, Delhi, with Professor Dr. Sanjay Gupta, who is our HOD and also the head of the Department of Transport Planning, School of Planning and Architecture, New Delhi. So the topic is, so the research is on evolving urban freight management strategies for a wholesale textile market, and the case study area is Gandhinagar Textile Market, Delhi. So this is just to give a context about the whole urban freight scenario, so which is from Niti Aayog and RMI report of 2021. So India is growing at a rate of 13% each year, and the logistic cost to the total GDP cost of India is contributed to about 14%, with employment to about 20 million people in India. So why does this research need come? So this is mainly to evaluate the wholesale market strategies, because there are obsolete infrastructures, there is decrease in productivity, there is high logistic cost, and there are no target-enabled interventions to site-specific study areas. Then coming to the aim, objective, and the methodology. So the aim is to develop the urban freight management strategies for particularly wholesale markets and improve their productivity. The key objectives include to assess the, to find out the urban freight management strategies from the literature review, then to assess the physical, operational, and the key traffic movement pattern of the site-specific context, to develop alternate freight management strategies, and then to assess the impact of those strategies and how they help in improving the productivity. Then this is the overall methodology, which has 7 stages, starting with the background study, moving on to the literature review, then to the selection of the study area, which is the Gandhinagar textile market, then coming to the data collection process, and moving through the data analysis, impact assessment, and the conclusion. So, so these are various literatures which have been identified from various global case studies. So there are no such relevant case studies that are implemented on the Indian context, particularly to the wholesale textile markets. So this study can be considered as one of its own kind. So these are some of the strategies that are mentioned out of, so total 14 freight management strategies have been identified, which are relevant to the Gandhinagar textile market study area. So some of them include the nighttime deliveries, urban consolidation centers, urban logistic and spaces and hotels, logistic parks, modal shift in planning, and electrification in urban freight. These are some of them. Then this is the overall detail of the city profile. So just talking about the freight profile, which is particularly our context of study. So about 2.46 lakh trips happen daily, every day in Delhi. About 6 lakh tons of cargo is moved around, and out of which 1.6 lakh ton is the intra-city movement. Then this is the survey design and the database. So I have conducted around a total of 5 type of primary surveys, including the Recce survey, establishment survey, out of which around 180 samples were collected. That is 5% of the total establishments present in the Gandhinagar textile market. Traffic volume count for 3 hours, which has been extrapolated to 24 hours then. Transport operator and freight forwarder survey, 26 numbers. So this is 40% of the total. Total there are around 80 freight forwarders, out of which 26 have been surveyed. And freight vehicle driver survey, 74 samples has been collected. And these are some of the secondary data source that has also been used through the research process. Then coming to the Gandhinagar physical characteristics of the market. So this is the Gandhinagar textile market, which is around 70 hectares of area. Around 4,000 establishments are there, with the establishment density of 59 establishments per hectare, and the tonnage per unit handled is around 33 tons per hectare. So there are about 90% of wholesale units in there, and around 350, that means around 10% of retail markets are present within the market. Then coming to the supply chain, so this is the incoming supply chain of the Gandhinagar market. So as you can see, the chain moves from the manufacturers that are outside the NCT area, moving, and then they supply it to the transporters or the freight forwarders. They then transfer it to the wholesalers, and from wholesalers, it moves to the retailers. So a total of 2,290 tons, around 2,300 tons move every day. Then coming to the outgoing supply chain, out of the 2,300 tons in total, around 275 tons are consumed within the market, moved to the retailers, and rest around 2,000 tons moves outside the NCT area again from the Gandhinagar textile market. So the total inflow and outflow time comes somewhere around 100 to 180 minutes, and you can take 150 minutes on an average, which is actually a lot of time taking only the market region. So it takes a huge amount of time for the intra movement only. So these images also represent the same thing, how it moves from the transporters to the wholesale retailers. Then coming to the operational characteristics of the market area. So as you can see, I have divided into 3 legs, from manufacturer to transporters, from transporters to wholesalers, and from wholesalers to the retailers. So, here you can see from the wholesalers to retailers, around 92% of the trips are NMT trips. Then this is the tonnage handled by the time of the day, which is collected during the primary survey. So this is from 7 p.m. The operational hours are from 7 a.m. to 6 p.m. within a day. And this is how the total movement looks like. The highest tonnage movement is around 2 to 3 p.m. So that is the peak hour of the market. Then coming to the traffic characteristics. So I have conducted 3 hours of TVC and then I have extrapolated the data. So here you can see that the LOS of this is the Gandhinagar Market Road, the one that is passing through right through the center of the market. So the LOS of the Gandhinagar market is currently, in the existing scenario, is LOS F. Then this is the relationship between the speed of the network as well to the tonnage handled by the time of the day. So this actually validates that the primary survey conducted and the data collected from the secondary sources are validating. As you can see, as you can see here, the tonnage handled. So this is the tonnage handled by the time of the day, and the peak hour is around 2 to 3 p.m. And here, similarly, you can see the speed on the network is the lowest when it is between 2 to 3 p.m. So this actually validates that the speed and the tonnage are correlative. Inversely relative. Then this is the traffic assignment, which is done using the Visum software. The inputs were the road network, the zone, the OD matrix. So then after the traffic assignment, the GEH value was calculated, which tells us that the model is run. The data that the model is produced is correct, because we can see the this is the observed value and this is the modeled value, and the GH value is 2.21. So if the GH value is within 5, then the model is usually preferred as correct. And these are the main issues after discussion with the users as well as the stakeholders of the market. So the main issues are congestion of the market due to idle parking, lack of idle parking, congestion of the market due to sorting of goods on roads, as previously we saw in the pictures, time loss due to utilization of NMT modes, and absence of dedicated parking facilities. Then coming to the ranking of issues using RII. So a relative importance index has been used to rank those issues. So the final ranking comes like this: congestion due to unregulated two-way freight movement is the highest, and then the time loss and congestion due to encroachment of streets. Then application of AHP. So AHP has been used to rank those strategies. So 6 strategies have been finally taken up, and this has been ranked using the CIE index and the CR index. So finally, zone-wise staggering and urban consolidation centers are the most efficient ranked strategies as per the AHP. Then this is the description of the alternate strategies. So I'll just quickly go through it. So zone-wise staggering is a process in which we divide a market or any particular area into various zones, and then we open the market in particular days and then close the same part of the market on particular days. Suppose on Monday, Tuesday, and Wednesday we can open zone A, and the other 3 days we can go to zone B. And UCC, as we know, is this is a free complex center in which all those goods are kept and sorted. So then coming to the evaluation of the zone-wise staggering. So again, this has been done in Visum. These are the model inputs. And finally, we can see in the base scenario, the LOS was F in the Gandhinagar, in this Gandhinagar Market Road, while in strategy 1, we can achieve LOS C if this is being implemented, and we have a 44% improvement in the speed. Then similarly in strategy 2, again the Visum model has been done, and here we can see in strategy B, in strategy 2, we can achieve LOS B compared to LOS F in the existing scenario, and the change in speed is 50%. So this is the improvement in the change of speed. Then finally, this is the comparison of both the strategies with the existing scenario. So as you can see, I have taken 5 KPIs, that is freight trips, passenger trips, total trips, daily vehicle kilometers traveled, and average delivery time. So here you can see that strategy 2, that is the urban consolidation center, provides the maximum benefit in comparison to the base year scenario. So then finally, this is the conclusion which tells about the productivity index. So these 4 key performance indicators have been taken, and the productivity index has been calculated. So this clearly states that the productivity index of strategy 2 is more. So this is more implicable for our study area. So finally, these are the conclusions and recommendations. So the role of a planner here is to identify and understand alternate fleet management strategies and to evaluate them based on the KPIs that are related and that are relevant to the contextual site study area. Thank you.
Yeah, thanks, Smith. Questions? Yes, please. Your mic.
Ajay, you were mentioning about the time loss for the freight transfer. So what about, many issues you have taken, but one factor is there, which is the time loss for the transferring goods from one mode to another mode.
Yes, sir.
So have you done any study on it?
Yes, sir. Actually, actually the time loss can be seen. If we compare the NMT modes and the motorized modes that are within the market. So motorized modes include like goods, autos, but NMT modes include like...
Wait. My question is that transferring good from one mode or one thing, warehouse is there,
yes,
and transferring it from on the truck or sorting it on to the different ways or different,
yes,
some parcel you are sending through rail, some parcel you are sending through truck,
yes,
some parcel is like distribution. So how that time will be calculated?
Sir, actually for this survey during the research time, so I had actually followed each mode of vehicle while they are carrying a particular amount of goods within their capacity. So I followed and calculated the time taken from one destination to other destination, particularly from the wholesale to the retail shops. And likewise, I have calculated. Then I have extrapolated taking the tonnage and the vehicle mode, and then the final calculation set has been done.
Okay.
Yes, sir.
Thank you.
Yeah,
Thank
it's
you,
a nice case study to have. Do we have further questions? Yeah, please.
As you said, option A or B,
Yes,
both side है ना? The particular days में A side open करने का,
Yes, yes.
B side particular days open. In this regard, have you done any study of that particular area business जो shopkeepers है, उनके yes no analysis?
Yes,
etc.?
yes, sir. I have, yes, sir. I have actually done that thing that you have
But
been
it's
asking.
not mentioned in there.
Yes, yes, sir. So actually, all the inputs from the key stakeholders, the key stakeholders include the free transport, the transporters, the wholesalers, the retailers, as well as the association which controls the whole market. So all their opinions has been taken on this, and they have actually agreed, I mean more than 50% have agreed to do the zone-wise staggering as well.
Okay.
So they are in line with the research.
Okay, thank you.
Yeah, thanks. So, any questions? I was just a minor point. I mean, your LOS was based on V by C.
Yes, yes, sir.
And the C is, how did you estimate the capacity?
Sir, capacity actually that is a two-lane road, two-lane undivided road. So IRC has been followed. Yes, yes, right.
Yeah. Anyway, there are capacity inherently is quite uncertain on Indian roads. So how do we treat? There is a fundamental question. I just
yes,
thought
sir.
of
Yes, sir.
pointing
Matlab, sir, both the function has also been considered. As per the IRC, only we cannot take the number of lanes. So both the number of lanes and the function, both the things have been considered into the research.
Okay. Thank you, Smith, for presenting this.
Thank you so much. Thank you everyone for your time and patience.
So the next paper is by Bala Ishwari Macha. Yeah. It's co-authored by Deba Pratim Pandit. It's nicely titled as Property, Planning and Profit with an allegory. Good. Yeah, let's hear about it. Yeah, please try to wind up in 12 minutes and we'll have some time for discussion.
A very good morning to all the delegates that are present here. And I'm doing my PhD research at IIT Kharagpur in the Department of Architecture and Regional Planning. And this is a part of my research where we are trying to work on how a TOD framework can be developed specific to India, taking lessons from all the success stories from other countries and also making it specific to India. And I would like to give a heads up before going ahead that this is mostly based upon the qualitative research, and we have tried to build upon the case insights that we have learned from other part of research under my work itself by understanding what is happening in different cities of India, especially the Tier 1 cities. So I'll be showing some inferences of that, and then we have identified the key indicators that are important in TOD, and we tried to make it into a framework using a different approach called system dynamics approach. So this is the crux of the presentation flow. So the title goes by Property, Planning and Profit, the interplay of land assembly, floor area ratio, markets, and how these interacts in India's transit-oriented development. So as we go by the definition, we understand by it that it is an interaction of various aspects. We talk about accessibility, walkable streets, we talk about mixed-use development, but we also need to understand how these needs to be achieved. So for that, I primarily would refer to the success case studies that we have seen across the world, starting from Rail Press property model, which is very famous from Hong Kong inferences, where the private developers worked along with the government to bring success for the transit development in a case of China. And if you see the Tokyo's example, where when the railway network is planned, rail and property agencies together have led the development of the transit areas in case of Tokyo. And if you see the Paris example, there the state government has been actively promoting the regulatory aspect was streamlined so that the implementation is followed. And in case of Portland also, the growth boundaries were identified and planned. So if we see what is happening in India, what is the issue, or transit has been, is like an induced initiative. Already there is a lot of demand, already there is a lot of congestion. So it has not been planned from an initial stage, especially when you consider the metro. So what happens is, like, when we see as a transit oriented development, the general idea we get is, okay, we will expand to the suburban areas. We will, so that we will improve the access and then provide infrastructure because we have land over there. But what happens in case of brownfield areas, which is already congested, which has a lot of mixed use potential, like the core city areas? So what are we doing for such kind of areas? So we have to go for retrofitting or redevelopment approaches, which emphasize on the transit oriented aspect. Only then we can connect the core city areas with the suburbs, rather than we have seen some case studies in abroad in the research that just expanding the network and improving the suburbs is not gaining any ridership, and at the end metro goes into loss and TOD becomes a failure. So that's why we try to see how these important factors are interacting. So these are some issues. We have 3 key policies that are there in India which guides TOD or metro rail development. We have metro rail policy which has come in 2017. We have TOD policy which has come again in 2017. We also have land value capture framework which also came in 2017. So we can clearly see there is a shift towards understanding transit or importance of metro from 2017, but still there are some issues because we have very outdated building bylaws. We refer to 2006, 2016, some modifications were there in some states. So these were the major issues, and there are issues in land acquisition processes. So these are all leading to overall delays, and when metro is not functional or when there is no proper coordination between the developer or the private agency who is implementing the metro and the government, these lack of coordinations are not leading to the expected development that we are looking for as a TOD as a benchmark. So how can we address these things? If you see overall TOD research in the global, these are the key dimensions which you can categorize into. One is concentrating on regulatory and institutional dimensions, which is focusing on how the FAR, master plan integrations, land pooling schemes, all these things were there in other cities and how they are helping for TOD. And the market and financial dimension, mostly talking about the economic aspects like the land value capture, how it is happening, whether it has been captured properly or not, and how the mechanisms like TDR and all can be utilized, and how the real estate markets, very few studies were there considering the developers and real estate perspective, mostly talking about the land value increase because of the transit corridor and how people are getting displaced, leading to social issues such as like gentrification and affordability issues as well. And if we see the emerging shifts, as per the concept, TOD generally focuses on the 5 Ds and 7 Ds, density, design, diversity, demographics. But then now the shift we can see focusing mostly on FAR mechanisms and integration with different scales of plans. We can see this shift in the global studies as well, and concentrating on financial sustainability because that is what has found lacking, because the concept is 30 years old, but if we see in case of India, it's still evolving, I would say. And the social inequities are there, which needs to be taken care, especially in case of India, prior to getting or reformulating the TOD policy or implementing some amendments within the policy. This needs to be taken care. And the last one is there needs to be some integrated approach with all of this coordinated, which we are trying to establish. And it's not a very new. Integrated approaches were tried and are been talking since last 4 to 5 years in the global TOD research as well. Through a system dynamics approach, which we can achieve this. This is actually a industrial engineering concept, and this approach sees there is interaction between different domains. Like increase in FAR, let's say we are giving an increase in FAR incentive from the government side, then the developer will use that FAR, which will lead to increase in development. So developers show the interest to develop it. But then it will also increase the land price in that particular area. So to what extent we have to increase FAR? That needs to be again strategically looped based on these increase in land prices and all. So this approach or this methodology talks about that every function happens in a loop system or feedback system. One change in one aspect leads to the change in another aspect, which is either in a positive way or in a negative way. So we try to identify the indicators and then we try to categorize them into these frameworks: property, planning, and profit. So when we talk about property, it talks about the individual's perspective or the land related aspects, and planning is the regulatory things, and the profit is the developer's side. And these are some of the insights from different case studies. I would not like to go in detail of this because I'll show you the framework that we have trying to build. So these are the indicators, and I would not say they are strictly categorized into each sectors. There is an interaction among these sectors. So you can see there is an interaction of the factors. Like for property, solely land assembly and land holdout are like specific plot related issues, but then there is a planning and property nexus that is happening, which is talking about social affordability norms and social inequity concerns. So there is an interaction of all these things. Overall, we can measure these through perception of TOD and quality of life indicators. So we try to develop how each of these are interacting in the system dynamics framework. So this model is developed in a software called VenSim, which is used for system dynamics approach works. So here we are trying to, I'll just brief out these interactions. So increase in FAR would lead to increase in developers' willingness and increase in redevelopment opportunity, and which would lead to increase in ridership. And if the redevelopment has happened and the occupancy rate has been achieved, then it would lead to again more market demand for development, which will again increase the land price. So there is a need to put cap on FAR allocations from the government side to not to go these interactions to an extreme end. So such kind of interactions we try to identify, like there needs to be a cap on the mixed use thing, and first and last mile connectivity will increase the overall ridership and developers' willingness, because when there is access, people try to reside more in that particular area rather than depending upon the car, which we are, I think, discussing throughout these 3 days in other sessions as well. So these are the growth loops. So which is like a positive feedback on each other. And we also have the balancing loops, like we should put some constraint on some other aspect, like affordable housing, parking provisions, restricting parking provisions. So these are called balancing loops, where like increase in something will have a negative effect on the other. So these are the takeaways we can do. Like for policymakers, we can identify FAR and policy regulations on parking. These things they can work upon. Metro agencies can work on hand in hand with the developers and also the government. And for planners and the municipalities, the mixed use and last mile connectivity aspects can be the takeaways. So this is the first part of the model, and after this, more detailed mathematical calculations are under the process of our work, which is called as talk and flow diagram. Once that is developed, on-field data will be built into this, and scenario testing is possible through this approach. So we try to categorize these things into 3 aspects of planning, property, and profit, so that it gives a holistic approach of the all integrated aspects within the TOD. And yeah, these are the selected references. So this overall system dynamics approach is the key contribution of from this research.
Yeah, thank you, Ms. Bala. Yeah, it's refreshing to see an emphasis on the a qualitative methodology that underpins system dynamics on this aspect. Questions, anyone? Yeah, I have a few questions. Perhaps it's also about the micro details on the software that you used, which I will not, I'm not asking them now. Perhaps we can have it.
Student version software available openly when you do such kind of simulation. So in the next stage also we'll be using the same software. We can build the equations within it, and that is under the process.
Sure, I was more concerned about what goes in. Maybe we'll discuss that later. But anybody else? Yeah, please.
So, good presentation. So you emphasized a lot on FAR and its positive and negative impacts on land prices, for example. So one more thing I wanted to ask is that are you considering permissible FAR or purchasable FAR? Because one thing FAR has a high linkage to is road widths, and in most of the Indian cities, road expansion is a challenging issue. How have you incorporated that into your model?
Yes, so we can't go just by the permissible FAR. We have to go by the maximum FAR as an estimate when we are building such kind of models. And especially in case of TOD, we should always consider maximum FAR as a cap, because you can, like since this work is mostly policy related work, if we take the minimum FAR, we can't see what scenarios it will happen in the future. So there will be scenarios with both permissible and maximum FAR with varying changes in the affordable housing aspects, because currently the government mandates 30% as affordable housing, but then there can be variations in that. We are talking to developers like what percent they are interested to do, because 30% might not be giving the profits that they are expecting or anticipating. So we are trying to make it a feasible model for not just from the government side or the concept side, but so that everyone can work in the nexus. So that's all I could say for now.
I think, and the very essence of the methodology is that you can try both.
Yeah, we can try both. It's just like the framework we are giving. So it's our goal is to give the framework so that every city can experiment with their own inputs. Like
and your maximum FAR becomes a node in your next model.
Yeah, because in case of Mumbai, the higher FAR is 7 in some TOD areas. But in case of other places, like in Hyderabad, As of now, it doesn't have a policy, but it's just 1.5. So there is a huge variation. So that can be predictable through the framework.
Okay, thanks. Yeah, thank you, Bala. We'd move on to the next presentation by Sitanshu Kumar Das. Yeah, please stick to the 12 minutes time in the interest of time. Yeah.
Yes. Good morning, everyone, respected delegates. I am Sitanshu Kumar Das, pursuing my PhD at NIT Roundtable under the supervision of Professor Prashant Kumar Bhaiya and Professor Mahavir Panda. Overall, if you will see the toll gate operation, it is being mandatory in India to use FASTag for toll gate transactions. And if we will be focusing on the total delay, what is being faced by a vehicle, it is not restricted to the transaction which is being carried out at the toll gate. It starts when a vehicle approaches the toll gate, and it is the delay like deceleration delay, delay due to queuing, delay due to service time or service period, and acceleration, delay due to acceleration. And all these 4 parameters will subsequently feature the total delay for a toll gate, and focusing how the service time and the current research is focused on service time, and it will be reflecting to the service time delay. The topic is analyzing the effect of service time in FASTag based toll tax collection system in India. These are my contents. Coming to the background of my study, public-private partnership model is preferred for a highway development in India, and to private concessionaries recover these investments through toll collection. And India has implemented FASTag toll collection system through radio frequency identification system, RFID technology, and it is being observed that 90% of toll plazas in India now operative under FASTag as per 2024 data. Then despite modernization, operation challenges are there, like RFID reader malfunctions, network delays, poor lane discipline, like we have mixed traffic scenario in India, and we do not follow the lane discipline, and if a lane and the vehicle users or road users try to join the minimum queue. My research objectives are analyzing service time variation under mixed traffic conditions, examining different vehicle categories at selected toll plazas in India, particularly in Odisha I have considered for this study, providing empirical insights into factors affecting service time, proposing strategies to enhance the overall performance and reliability of India's electronic toll collection system. These are my literature reviews which focused on service time study at toll booths, both in manual toll collection system and electronic toll collection system. Few studies only being this type of study is being taken by few researchers of India, for particularly focusing in India, and very few studies are available for electronic toll collection system. My methodology for the location, I have considered one Denkikot toll plaza, which is situated in Keonjhar district of Odisha. The data is being collected between 14th to 16th November, and between the time the peak hour is being found like 9 to 11 a.m. and 4 to 6 p.m. And there were 5 lanes were operational on the day of data collection. Videographic data has been collected, then analysis is being done and focused on mixed traffic across different vehicle categories and different lanes. Service time defined as the duration between vehicle arrival and the boom barrier opening. Then analysis for data analysis, descriptive statistics to summarize the service time patterns, probability distribution functions to model service time variation, then ANOVA test to assess lane-wise variation in service times, focus on factors affecting service time across vehicle categories. These are the various vehicle categories taken for the study based on the length, based on the average length of vehicles. And then descriptive statistics of service time shows there are mean service time for small cars, it is around 6.553 seconds, and followed by big cars and different category, other categories of vehicles. And the key observations for the study: heavy commercial vehicles have the highest service time around 19.51 seconds, and LCV are having 4.57 seconds, and big cars show the highest skewness 3.44, indicating occasional extreme delays. MAVs has higher service times comparable to HCV, but with slightly less variability. Passenger cars like small cars, big cars and buses generally process within 15 seconds for most of the cases. So this is the service time distribution for as per vehicle with respect to vehicle types. Heavy commercial vehicles and multi-axle vehicles, MAVs, experience significantly longer duration for service time. HCVs show highest variability with a skewness of 5.755. MAVs have the highest mean service time at 17.018 seconds. The box plot clearly indicates that larger vehicles have disproportionately higher service times and greater variability, highlighting the need for specialized lane management for heavy vehicles. So then ANOVA analysis have been done to conduct, to assess whether mean service times differ significantly across the 5 operational toll lanes for each vehicle category. It is being found that large and high for passenger cars, there are large and highly significant lane effects. For buses, significant differences across the lanes. For commercial vehicles, marginal difference between the lanes, and for HCVs, no significant lane effects. These findings suggest that factors related to lane technology and payment methods rather than the vehicle class itself are primary contributors to service time variability at the toll plaza. Then few models have been checked to find the best fit model for service time, and it has been found that for smaller vehicles like small car, big car and LCV, GEV, Gaussian GEV distribution as common best fit model for smaller vehicles, and for larger vehicles log normal and inverse Gaussian distribution found to be suitable. Log logistic and GIG distributions appear to be good fit in some specific lanes. Finding reflects operational conditions and driver behavior. Then key findings from the study based on vehicle types. Service time highly dependent on the type of vehicle. We can find that I have shown already the different mean time for different categories of vehicles, and for considering the high skewness for service time, for HCVs it is around 5.76, and for big cars it is around 3.446, and maximum delay sometimes observed for big cars around 73.36 seconds, and for MABs around 87.64 seconds. Indicates occasional extreme delays in the service times. Heavy vehicles normally faces higher service time delay or some maximum service time during the transaction. And for lane specifically, it is also significant lane effects for passenger cars and buses. Marginal differences for LCVs and MABs, no significant for difference for HCVs, lane technology and payment methods are dominant sources of service time variability. From the current study, we concluded that the analysis confirms that service time varies significantly across vehicle categories, with passenger vehicles generally processed faster than heavy vehicles. Heavy commercial and multi-axle vehicles exhibit prolonged and inconsistent service durations, largely contributing to toll plaza inefficiencies. Statistical results further indicate that lane technology and payment methods are more influential and vehicle class in determining service time variability. And for different models, we cannot specify a particular model for all the lanes and all the vehicle categories. For specific categories of vehicles, some model is being found to be best suited, and for some lanes also it is like that. Overall, the finding emphasize the heterogeneous and stochastic nature of toll operation and highlight the importance of customized lane management strategies to enhance the toll plaza efficiency. Considering my future research, hybrid models can be developed depending upon the type of vehicles and lane specific service times. And the more studies can be taken out by exploring the machine learning and simulation techniques to dynamically predict service time, and considering the driver behavior, traffic composition and lane assignment strategies in the model. And this has to be validated with a large set of data. These are my references.
Yeah, thank you, Sitanshu. Any questions?
Emergency vehicles were considered as part of the study?
Emergency vehicles like ambulances, etc., those are not being studied because they have specific lanes and they are not paying the tolls. Right. So they are not supposed to wait at the toll gates.
So the definition of the service time that they are making is till the from the vehicle stops and when the boom barrier opens.
Yes.
So there is no boom barriers for emergency. I think that's what you're saying.
Yes.
Excuse. What are the major reasons for the increasing service time? Is it inherent to the vehicle, or are there any external factors like behavior of driver? What are the reasons for increasing the service delay with respect to the increasing size of the vehicle?
Sir, these are service time is dependent on various factors. Like if there will be a technological failure in RFID scanner, and also placement of FASTag on the vehicle, and it also depends upon the size of vehicle. Yes. If FASTag is being placed on the car or on a truck, the height, there will be height difference. So scanner may, the RFID scanner may do it for due to difference in height. Sometimes scanner is not able to scan it or process it properly.
Okay. Instead of the dedicated lines, can we attend to these technical issues so that it will improve?
Yes, sir. Yes, yes. Sir. That is the.
So, if I may intervene, in fact, there are studies which says, if I remember rightly, what matters to be specifically is the relative angle between the readers and the pitch of the windshields of commercial vehicles are more vertical. Cars, like light vehicles, are inclined so that it picks up. Maybe you have seen this, but which also emphasizes the relevance of having separate lanes, because then or somebody will have to bear the extra cost of having more devices to read, or maybe
if you can be specific for a particular category of vehicle, then it will be more efficient to.
But still, the question remains of let's say a heavy vehicle.
Yes,
different sizes of heavy vehicles also have an effect on the timing. That is not quite clear why it happens. So that's the elephant in the room. Anyway, thanks. We'll discuss about that. Any questions? Any more questions? If not, thank you, Sitanshu.
Thank you, sir.
Next, we have Amardeep Pandey.
Good morning, all of you. My name is Amardeep Pandey, and I came from one of the oldest civilization on the earth, Varanasi, and I belong to IIT BHU. Basically, I'm going to present my research on vibration-aware traffic management framework based on vehicle-induced emission and route-sensitive analysis. This is the first kind of study in the world. So basically, I'm proposing a route, a vibration-sensitive route, which will optimize the vibration of that corridor as well as the mobility of the vehicle. Now coming to the next slide. Now, as we all know that the India heavily relies on its road network, because we we have got 60% of our transportation that has been done through the road network, which is just half for the China, and for the European countries it is like 10%. So we heavily rely on the roads. And now coming to the second part of my introduction, then in the figure it can be seen that there is a figure between the road length as well as the number of registered vehicles in India as for now. So it can be seen that there is a drastic imbalance between this since 90s, so which is again causing the problem to our urban setting, and hence the increasing the pollution. So basically, the major pollution that we feel that like air pollution and noise pollution, but there are some research and studies have been done earlier which says that there is a vibration problem associated with the transportation is there. Although they are often, but also the transport agencies do not have even the proper guidelines along as in India to counter this sort of problem or to resolve these problems. Now coming to the vibration part, then basically it's a source, transmission path, and the receiver kind of problem, which is there in the ground in the traffic-induced vibration. So basically, what my research gap is, there is a lack of routing framework that enforce corridor-specific vibration limit while minimizing the travel time. So basically, this is my objective. Basically, there are 3 standalone studies which I have already done, and it has been published in the research papers. So first is the classification, second is the standardization of the matrices, and third one is the finding the best route. So combining all these studies, I am proposing a unified vibration-aware traffic management framework. Now coming to the instrumentation part, this is accelerometer where then the sound level meter, then the lidar speed, then for speed, then the camera, then this is the accelerometer mounting device, and this is the on-site setup that how it will look. Now coming to the accelerometer part, so basically this is the accelerometer, this is a triaxial accelerometer which captures the acceleration in 3 directions, X, Y, and Z, and this is the mounting device that we have fabricated in our lab, and also we are now filed it for patent. Now coming to the signal processing part, the instrument accelerometer gives the raw signal, and which we process through the signal processing method by using band pass filter, windowing, and signal standardization. Basically, signal standardization is the method in which we have to focus that when the vehicle is passing by. So we have just cut out the 1 second window of the maximum energy of the total signal for the vehicle. So basically, this is my study site for first 2 studies, like reference vibration emission level and passenger car vibration equivalence, and the vehicle classification study. So basically, we have got 4 sites for Gorakhpur along the NH24 highways. Then basically I will not go into the detail because it will require too much time to understand. Just for the brief, I will tell you that when the vehicle is passing, it is exerting some vibration on the road pavement, which we have captured through the accelerometer. And by the processing, we have achieved our first study like vehicle classification. We have classified the vehicles in 8 categories, and we have achieved like 99.7% of accuracy. And then this is our second study in which we have quantified the vibration like reference vibration emission level and passenger car vibration equivalence. So basically, reference vibration emission level is the linear regression models between the speed and the vibration matrices of the particular vehicle. So we have got 11 classes of vehicle in it. So that is like max average power and RMS value of that acceleration value. And then passenger car vibration equivalence is the same as the PCU in the traffic that we use. So basically, for a particular vehicle class on that particular speed, how much times of car it is equivalent at that particular speed. We came to know about it. Then this is the third study that we have performed. So we have taken like 52 sites, 20 at Varanasi and 24 at Gorakhpur. So there will be around 18 hours of continuous vehicle monitoring using the camera, and we have we have got the we have extracted the classified vehicle count through the manual counting, and we have incorporated it with GPS. Actually, I would like to tell you something, that if we are, suppose we are moving from one place to another place, and if we are using GPS, so suppose there are 2 or 3 routes is there, okay? So suppose when I just put my data into the GPS, then it will show that this route having red, this route having green or something. So basically, this is basically how many occupants are there having the mobile with GPS. So if there is, suppose on a particular road there is a bus, okay? So in the bus there may be 80 to 100 passengers over there, so 80 mobiles are there. Or suppose in another route there are 10 trucks, each truck having maybe 2 to 3 person, so maybe 30 is there. So if there is more trucks in one side and 2 or 3 buses in either side, then the buses size has lower PCU at that region, but it is showing the red line. Okay, but in the case of truck having PCU higher than the other route, but it is showing the less. So that's why the discrepancy has happened. So what we did, we have taken corridors from our Kashi Hindu Vishwavidyalaya to Kant, and we have got 3 routes. Okay, so what we have did, we incorporated our classified volume counts based on some points over there at the intersections, and then we came up with the idea that along with GPS we have to give our, this is the study, along with GPS we have to give our classification, like is it an excellent road, excellent choice, good choice or worst choice. This paper has already been published. I will not go into the detail, you can find out. And then this is the main thing which I am going to present. So basically, suppose from one place to another place we have to move, okay, and there are 2 routes like A or B. So first of all, driver want that I would move from that road which is causing less delay, okay. So but we have to think that whether the route is on some sensitive structures like some monumental structures, some laboratories or some hospitals, okay. So which is causing again means the vehicle is causing problem through the vibration to them. So first of all, we have to identify that which route we are planning to adopt the framework. Okay. So first of all, we have to give the threshold values, like for vibration value as well as the total dose of the vibration and at that particular time. Okay. So basically, incorporating my 3 studies, suppose when the vehicle is approaching to that junction where he has to decide that whether he has to take route A or B. So first of all, accelerometer and speed guns were installed. So from the accelerometer, first it will classify by my first study. Then whether if it has classified by track, then from my second study, it will calculate the vibration level at that particular speed for that particular vehicle, and also it will tell that how many from passenger car vibration equivalent. Passenger car vibration equivalent. It will tell that how much car is equivalent to that particular truck. So and also we have to incorporate that classified volume count for to minimize the delay, as in my third study was there. So basically, route 1 or route 2, there will be 3 cases. Both routes are sensitive. One route sensitive, other is not, and in third case is both routes is not sensitive. So suppose we are now going for both A and B routes are sensitive. So suppose both A and B routes are sensitive, then first it calculates what is the actual vibration of that particular truck at that time. Okay. So it will match with the threshold limit. If it is in the limit, then it will allow. Otherwise, it will try to recalculate the reference vibration emission level using my study and try to find out the speed on which the truck can move from this. So if it is happening, then it will allow the truck. So and one more thing, and if it is not still in our limit, then it will die. It will not let the go to truck. But there is also one case that suppose for a corridor there are number of vehicles already there which is causing the problem, which we can say that at the particular time there is a noise dose has been increased. So it will not allow the truck to go until unless that much vehicle will be passed, so that the total noise dose will be not exceed. And in second case, for sensitive route, again my RVEL part will apply, and for non-sensitive zone, it will try to minimize the passenger car PCU value as well as the vibration value as than the delay. Then for non-sensitive route, generally for lower PCU value and delay, it will go. So basically, combining all four, it will give you the route ID, means which route you have to adopt, and also there will be a speed limit, a speed cap limit. Yeah, sir, yeah, it's okay. So basically, there are the few findings of mine. First one is that we have proposed new indices, and also we have got 99.7% accuracy in classification. Then we have incorporated GPS with augmented GPS for the route optimization. Then combining all three, I am proposing this vibration aware management traffic management framework. Thank you, sir.
Yeah, thank you. Questions? So this, Amar, vibration is being taken as a proxy for noise alone or noise and emission?
No, vibration is based on traffic-induced vibration, sir, from the ground vibration.
Yeah, but why are you enforcing or why are you managing based on vibrations? What is wrong if vehicles vibrate?
So, sir, if there is a monumental structure, there are certain routes that we have to identify that whether it is a sensitive zone or not. So there may be some corridor in which having the monumental structure or the building structure are means very near to the roads. Okay, so which is causing the fatigue to the building. Actually, the main problem is that this is not an earthquake, so we cannot see that visual change in less time. Okay, it will take like 10 to 20 years to show the crack. So the building which we supposed to develop for like 80 years will be there for like 40 to 50 years. So that's why I am emphasizing. Basically, this is a proposed framework which government has to adopt if they wanted to means.
So it's relevant for the structural aspect.
Structural aspect, yes, sir.
Of the buildings on the way.
Yes, sir. Buildings and the bridges as well.
Yeah, but wouldn't it be also because if you can relate vibrations to other negative externalities like emissions, like noise, then perhaps for any city, I mean even with cities with only new buildings, let's say, even so those cities might find this applicable. It's nice thought to have in that sense.
Sir, actually we have done this noise study as well, but I have not presented here.
Oh, I see.
Noise and vibration we both covered. Actually, when we come to our first slide, if I may.
No. So you see that there is a relation between noise also.
Yes,
right?
yes, sir. Basically, this is an Imprint India project that we have awarded from IIT Roorkee to IIT BHU is the partner institute. So that's why this studies came. Actually, there are some other studies as well, but for this presentation, I focused on this vibration kind of thing.
Perhaps also emissions is what I'm thinking. I don't know.
Yeah, sir.
Emissions
I have done
also.
study. Yes.
Okay.
In the building as well.
Right. Anything else?
So just one question.
Yes.
Here. I think it's a very innovative. First time I'm hearing about vibration.
Yes, sir.
I understand the problem. What is a simple mitigation measure for reducing of vibration and damaging impact of the heritage buildings or any buildings?
Sir, basically the conventional method is to dig a ditch, to dig a hole, to make a stretch. Okay. So when you dig it, then the vibration will not pass. But again, there is a problem. If you can't dig it, then there are certain materials. Basically, we have to think that there are two things. One is the amount of the vibration, and another one is the frequency. Okay. So suppose the monumental frequency has some natural frequency, and the vibration which is coming from any other source has that natural frequency, then it will create resonance. So there are some materials as well as we have to increase the distance. There are certain methodology we can plant something. So that we can also do the soil improvement as well to mitigate this.
There's a solution.
Sorry?
The solution can be found out, right?
Yeah, sir. Solution can be found based on the specific sites. Maybe in foreign countries they use dampers to mitigate this sort of vibration and also the earthquake.
Thank you.
Right. Somebody else had a question? Yeah. Okay. Thank you, Amar.
Thank you, sir. Thank you, sir.
Next, we have Sujit Sahu.
Good morning, all. I am Sujit Sahu. I am presenting my research on perceived truck level service for suburban roads. Insights from Indian truck driver using Bayesian regularized neural network. I am doing my research under the guidance of Prasant Kumar Bhuiya sir, Associate Professor, NIT Rourkela. So the motivations for the study is, as we all know, the service quality assessment has always been in terms of level of service in Indian cities. So it is very common that trucks are not allowed in city centers during daytime. So most of the trucks for the freight movement rely on the suburban areas. So freight movement is vital for cities' economies and is facing severe operational challenges in suburban areas. Truck also share an Indian heterogeneous condition, share the same, same space with cars, two-wheelers, and other modes. The existing LOS work are on basis of converting the total traffic into PCUs that is on car-based, and it lacks the unique performance and perception required to observe the truck drivers' service level which they face during those routes. Poor truck mobility will lead to logistic efficiency, delivery reliability, and contributes to urban congestions also. So the need for the perception-based or human-centered data-driven technology for service quality assessment is much more required. The research gaps in existing condition are conventional LOS models use only single parameter as a measure of effectiveness to represent the service level. That is either delay, speed, or operational speeds, or volume to capacity ratios. Truck performance is influenced by multiple variables such as road width, maneuvering space. Since it is a very, trucks have very limited maneuverability. It cannot access the road as other modes, and surrounding traffic composition, which are often ignored in the standard protocols we currently follow. Very few studies have integrated perception-based level of service. So there is and most important thing in handling perception-based data is it incorporates large amount of heterogeneity and nonlinear relationship between the variables and the perceived service level. So integration of machine learning models is a key point for the framework. The objective of the study is to develop a perception-based truck level of service for suburban areas and to analyze the key influencing variable. Those are effective road width, available shoulder width, payment condition index, percentage of truck, speed ratio of free-flowing condition of truck to other modes, presence of street light reflector, obstruction due to other transport, volume to capacity ratio, and there are other variables which we further process into modeling. The current study used a Bayesian regularized neural network modeling technique for modeling the perceived level of service for trucks. The model performance which we observed are quite good. That is, for the training we observed about 0.91 R square value, and for testing it is 0.86. And there are for a few recommendations for infrastructure development and truck mobility improvement. So the study framework includes data collection, variable selection, driver survey, and on-field data collection, training the BRNN model, and validation and recommendations. So there are total 33 sites where we collected data from different parts of India. So there are some considerations which should be kept as consistent during the selection of the sites. Those are for city consideration. It should have functional importance at some freight movement. There should be some important industry level development, or there should be freight movement, heterogeneous traffic composition, and the geographical spread throughout India. We do not want to localize our data collection to some specific places. For site consideration, we are focused on suburban areas where we can observe higher amount of truck traffic. And the minimum lane width what we observe as minimum 4-lane width, 4-lane roads were there. And we try to collect the data from the location where we have low side friction, that is low collector road interference on the suburban areas. So data collection is collected in two parts. That is the field data collection, where we have collected mostly from videographic method to collect the field data, and the other parameter which are physically measurable were collected by measuring things on field, and driver perception study, where a total of 3,015 truck drivers were surveyed for their how they will perceive while driving through the road from which we have collected the videographic data on a Likert type scaling of 1 to 7, where 1 represents lowest and 7 represents the highest value. And the respondent score were used to model the truck LOS. So the variable, there are total 33 variable considered, from which we used partial Spearman correlation to filter out the variable which we will be using, which are statistically significantly correlated to the observed truck level of service score. So the variable which are finally selected for the modeling purpose were effective road width, adequate shoulder width, that is if the shoulder width is more than 3, we observe it as binary variable 0 or 1, presence or absence, pavement condition index, volume to capacity ratio, percentage of truck traffic, free flowing speed ratio of truck mode to other modes, and standard deviation speed ratio for truck mode to all other modes. So this is the result of correlation analysis for partial Spearman correlation. So we used a significant threshold of 0.05%, and from the 31 parameter we tested for correlation, these are the variables which we will be proceeding for modeling purpose. So for BRN modeling, it is a already backfitting and regularized model, so it overcomes the limitation of overfitting, which generally observed in neural network modeling. It provides, it also generalizes our data by pre-processing it into normalizing, and it provides a good accuracy also. So 3 type of activation functions were tested. Those are purely time sigmoid and log sigmoid, where data was split into 70% and 30% for training and testing purposes. So 2 type of neural network we used, that is LMNN and BRNN. We proceeded with BRNN and its results were more consistent. That is, prediction values were more consistent. So this is the observed and predicted values for the truck alloys. We can observe with the 45-degree line that the prediction is quite accurate for BRNN truck alloys model. So it successfully captured the nonlinear relationship between the parameters we earlier extracted from the sites and the perceived value from the truck driver we observed. So the prediction algorithm of neural network is using, we can say the formula uses B1, that is the tan sigmoid formula, and the weightage for each hidden layer, which will be used, presented in B1, which can be finally used for predicting the truck alloys, is output layer B alloy bias for the summation of the each hidden layer's predicted value. So further, alloys has always been presented as a familiar letter grade system of A to F. So we used k-mean clustering with iteration where the centroids were stable, that is the changes is less than 10 power minus 3. So we classified it into 6 category A to F, with which represents the service level corresponding to the service score which we arrived from the prediction model. So we got the value for greater than 5.51, I have excellent service as A, and the prediction value which have less than like 1.35 are categorized into service level F, and the further categories can be shown here. So the conclusion will be the traditional operational indicator are like V/C ratio, the single parameter alloys values which we use to have performance analysis are insufficient to capture the suburban roads with high truck traffic. We developed a truck level of service framework which incorporated the actual driver, the actual user's perception into their satisfactory level as LOS analysis. It integrated both geometric, operational, environmental, and perpetual variables. And partial Spearman correlation analysis is used to filter out the variable which we initially captured to the only selected statistically significant variable which will be used for modeling. And using BRN network, we have achieved high accuracy of 0.91 training and 0.86 testing. K-mean clustering is used for changing it into familiar letter grade categories. And this represented a step towards a human-centered and perception-based transportation planning, which will be very helpful in developing smooth suburban freight corridors in future. So some policy recommendations are there, incorporating truck alloys as the performance analysis or performance indicator in suburban areas, since those are the areas which have a significantly higher truck percentage. So prioritizing infrastructure upgrade like shoulder width rehabilitation and road width enhancements. Using truck LOS to identify the suburban areas with traffic problems, and integrating driver feedback mechanisms. That is, once it is completed, then we may have other, we may also incorporate other features. So once we have satisfied driver, human behavior always changes with situation. So it should be a continuous process, and aligning our infrastructure development with driver comfort and safety and freight mobility chain supplies will contribute to a sustainable and competitive logistics system, which will helpful in ultimate end. Okay. So these are some of my references. Thank you.
Thanks, Sujit. Any questions? You can see that a lot of labor has gone in your data collection, and lot of so many locations, lots of data.
Yes, sir.
Yes, you did it yourself or in agency?
Actually, in our lab, we work as a team. So some of are collected by me, some of are by the MTech students who also collabed with me.
Right.
So for the means the perception data, actually that take the most of the time, because reaching truck driver and they agree to give, that is also already a less percentage.
Correct.
So the videographing and site data collection, those are mostly by me, but the perception, there is a lot of help from the master students.
Yeah. So while one can understand that perception-based LOS is relevant, I mean, you can't go on with this single parameter-based LOS in a complicated system. But why neural networks?
The perception-based values, actually, I have not shown here, but initially we also used statistical models. This includes complex heterogeneity, and sometimes even means, although we tested it with partial experiment for monotonic relationship, the prediction model also shows non-monotonic relationships also. So statistical models won't be able to capture those things.
Yeah, you have convenience of modelability. I understand if there's a word like that. But my question is, see, LOS is widely regarded as something that we can use to communicate between users and policymakers and designers. Now, when you say a host of parameters will influence my LOS, and my LOS is F, why? Because this black box tells me that it's F.
Okay.
That explainability concern that always has the risk
so that's why the final thing is we are clustering into familiar letter grade gateway, and there is a, I have not shown here, there is a sensitivity analysis. So we can prioritize that which parameter influenced by how much percentage to our final prediction.
Okay.
So in that way we can, means if we are achieving F like some places, we can prioritize that only improving by one parameter also we can improve this much percentage.
So you can attribute some meaning to the explanation. So some question, the observed LOS is based on which parameter?
Pardon, sir?
Your observed LOS. You compared your observed LOS.
Observed LOS is the mean value of the ratings that we observed from the truck driver, that is 1 to 7. So 7 is the highest, they are most satisfied, 1 is lowest.
So it's the mean.
So a mean value for all the truck driver for same sites.
Right, got. And some minor comments or micro details I would say. For example, I did not see an parameter that represents percentage of other kinds of vehicles.
We have used for those 31 parameters which we have tested for partial experiment. We tested that, we didn't find it significant.
So there were, for example, what truck drivers...
car and two-wheeler we have checked.
What truck drivers usually seem to complain is about the two-wheeler presence
for
and them...
signal, actually this is for urban road. For signalized intersection we found another parameter, that is the seeping two-wheelers. Those were inflecting. For our urban road we didn't find it significant.
I see, okay. Nice work anyway. So thank you. Any questions?
Thank you everyone for your time.
Yeah.
Okay, thank you everyone.
So that brings us to the close of presentations. We had 6 presentations here today. I think all were, I would say, thought-provoking discussions that we had, right from the framework for assessing multimodal integration. Then we had a talk on about the Gandhinagar market by Smith, and then the more qualitative lines on property planning and profit. FASTag based very practical study that we are all eager to know the reasons behind, and a very novel, I would say, an innovative vibration aware traffic management framework from which Amar presented. I can't see him here. Yeah. And then of course this level of service by Sujit. And then so I think this brings us to the close of this session. I thank all of you for being here and participating in the discussions. I hope tea or coffee will be awaiting us outside, where we can take our further discussions on to the coffee break. Yeah.
Thank you, sir. Thank you, dignitaries and participating authors. And my special thanks to Chairperson Professor B.K. Bhavatharan for managing the time so well, reviewing all the authors' PPT and smoothly conducting the question-answer session. I will like to request Sri Ravi Kumar, Under Secretary, Ministry of Housing and Urban Affairs, to kindly come on the stage and present a memento to the Honorable Chair of the session as a token of respect. Thank you, sir. As we conclude, I, Ajay Bahadur Singh, on behalf of Mahua, wish to express heartfelt gratitude to all the dignitaries and participants for their valuable contribution in making this session a success. Thank you all.